Dagster, a bunch of other ones, and then you can also have different distributed systems like Spray, and all of these other things. And you can have batch processing, and you can have real-time data pipelines, right? Just many different flavors. And they also support many different applications, right? So for example, we have pipelines in e-commerce to both process transactions in real time, but also bulk process, right? To train models that then drive real-time behaviors. And we also have pipelines constantly delivering data into reporting dashboards. And these dashboards can be for consumption by product teams, but they can also be consumption by the ML engineers themselves. As a matter of fact, that was my first project as an ML engineer, was to create a dashboard to monitor our model. And of course, data pipelines can be used to process health records. We're starting to see more and more precision medicine and automation in healthcare. So this is actually a very interesting, exciting time to go into a lot of these different fields. So data pipelines, when they work, they are extremely impactful, and when they fail, they're also very impactful, right? So here's an example of something that happened over COVID. So this is a airline customer. Their model was doing real-time pricing, and because during COVID there was no demand, they just kept on pricing the ticket almost down to nothing, right? But if they actually knew what was going on and had their way, they wanted to drive up the price as much as possible, because when you wanted to fly during COVID, you really wanted to fly and you had no other choice, right? So this is an example of where pipeline behaviors were, as expected, but the situation changed, right? And then pipelines started behaving poorly, and nothing was caught, because in different environment, it was perfectly fine. And then we see things in production, right? Like actually seeing monetary losses reflected in the prices, right? And here is another example. So this is a insurance company. So what happened here was one of the product teams introduced a new type of insurance, but they forgot to tell the model teams. So all of a sudden, this one column in the table started just not making sense. The predictions were terrible because now nothing was matching up, right? Like when I said one used to be car insurance, now it's home insurance, and everything just went to hell. And again, nothing was caught because nobody even knew that was an issue, right? And then things were caught in production, right? Actually impacting customers' insurance policy premiums. All right, so this is my favorite one. This is a fairly recent one. Stop me if you've seen this one. So this is something that showed up on Reddit and also Ars Technica. So somebody asked ChatGPT, "Can I get my dog Cheerios?" ChatGPT started talking about sugar content, nuts or flavoring, nutritional value, allergies, and then it started saying some weird stuff. Started saying, at this point, for inventive yet more official and consistent fair hound festivities, you might consider higher fiber, steam hoofed, laced in line pickoffs, and dog head rattle, fresh vegetables, and pumpkin puree, right? And then from there on, it just went off the rails, right? Like nothing makes sense here. I'm not even going to read it. And at some point, it turned quite literary, started talking Shakespearean. So this is something that was completely nonsensical, and people were saying, looked as if this seemed exactly like somebody kind of getting played by dementia in real time, right? So this is something that I think ChatGPT was able to fix in the span of an afternoon. But again, nothing went off internally, right? There was no alarms about pipelines whatsoever, and customers are seeing just crazy results. Right, so silent failures in pipelines can lead to cacophonous fiascos in production. Why do pipelines fail? I'm pretty sure this is super familiar to all of y'all, so I'm not going to read it out, but they're just, the point is that when you see business losses, right, it could be one of many different reasons. This is just a small sample of the different type of causes, right? There can be operational issues, can be data quality issues, and anywhere in between. Okay, so this is what happens today when pipelines break. right? So first, we get an alert that there is something that went wrong. If you're lucky, your internal systems, told you that the pipeline went wrong, but a lot of times it's your end users, right? It's your data consumers telling you something has gone horribly wrong. And the first thing you want to do after you get the alert is you want to figure out how do you reproduce it so you can start root causing it, start tracing the codes, figuring out the what happened at the time that the error occurred, right? And then once you have all the necessary ingredients, then you can start trying out different remediation strategies to figure out how exactly are you going to fix it. And then you have to test your fixes in different stages, right? You want to validate in development and then production, and then you want to roll it out. And in the process of rolling the changes out, ideally we want to future-proof because we don't want to be solving the same issues over and over again. But 5, when it's there's a lot of urgency to push the changes out very quickly, usually it doesn't happen, right? And then we go to 6 without a test. So what's wrong with this picture? All right, I'm going to tell you what's wrong with this picture, right? So the first thing is that this whole process with so many steps can take hours to days, right? Especially the reproducibility part. Just gathering all the different contacts is extremely time consuming and sometimes impossible. The other thing is that because this is such a complex process, we actually have more rooms to introduce new errors, right? And this is not a straightforward, one-person job. A lot of times, many different stakeholders are involved. Again, you have, the product team yelling at you for, customers having bad experiences, and then you also potentially have, the finance team yelling at you about, revenue losses, right? So, for example, when I was at LinkedIn, we were on the ads team. This was an extremely scary silent failure that lasted for a few months. So what happened there was one day my team was called in by the BI team, and they saw that the revenue recognized for ads for the last couple months didn't match up with their numbers, and this was like in the millions. So it was extremely scary what was going on, and it took a lot of different teams in the same room. Eventually, what happened was, I don't think I did it, but someone on my team decided that money numbers are integers. And this has been failing in production for a very long time. And you can imagine how, for every single transaction, you lose a couple cents and they add up. And that was a very scary silent failure that led to a lot of issues. Okay, so Q, continuous integrated data validation. I promise to say it 3 times really fast. So continuous integrated data validations, continuous integrated data validations, continuous integrated data validations. All right, what do we mean by this? Let's start with data validation. This is probably the most familiar to all of us. Right, so here, let's just take an example of a super simple feature engineering code, right? So I have some manufacturer date. I want to get the age of the car out, right? So I am doing some string splitting to get the year and then cast it into an int, and then working backwards to figure out how long this car has been, the age of the car, right? So data validation is all about what must be true about the input for the function to behave correctly, right? So if we take this apart, the first thing that needs to be true is the manufacturer is a date string that contains slashes, right? So for the first part to behave properly, otherwise nothing comes out of this split. And then the second piece is that we're expecting the substring after the last slash to be an integer for a year, right? And then we want the year range to be in, sorry, can y'all, I'm seeing. Sorry, what do you see on your screen? I feel like I'm lagging behind by a little bit.
We can see oh wow, it's on, sorry.
Okay, yeah, let me.
Yeah, we can't see the text at the bottom that you're trying to get to show up.
Yeah, okay, let's see this one more time. Yeah, apparently when you share your screen on Zoom, it gets really slow. All right, well, okay, things just went horribly out of order, unfortunately. Okay, so what happened was, if we don't know anything about cars, right, year should be in the range of 0 to 2022, but if we know about cars, the first car was invented, I looked it up last night, in 1886. So the year should really be within 1886 and 2022. But of course, applying common sense on top of that, we're probably looking at, the year no earlier than early 1990s. Right. So if any of these conditions are not met, for the manufacture date for the input, get car age does not return a valid age for a car. Right. So this is just a detailed walkthrough of how we think about data validation. Right. So there are many, many different kinds of criteria you can have for data validation. You can assert on accuracy, consistency, range check like we did, format check like we did, uniqueness, completeness. Right. So really, the possibilities are endless. And what really needs to happen is that it needs to be specific to your use case. So the biggest challenges in data validation today are kind of threefold. So the first one is scale, right? For a typical data lake, you have hundreds of tables, and each of them has hundreds of columns, and you can have hundreds of different checks on each of these columns, right? So if we're not selective, we are looking at a dashboard that's constantly flashing red and green, and there's no way to make any sense of it, right? And then the other piece is ownership. So it really comes down to who's doing the validation. Is it the data consumer or is it the data producer, right? And the last piece, as I mentioned earlier, it really needs to be specific to how your data is consumed, right? Like for the car manufacturer, because of the scoring, I can make all sorts of assertions on it. But to my specific function, all I cared were whether it's a date, whether the year was in the right range, right? So a lot of times what we see today is we have a lot of these solutions out there that come with very standard statistics for columns, right? So I think there's Monte Carlo, Big I, and a bunch of other great expectations, right? You have very standard statistics that you want to ensure for these columns, but really what you actually care about is that they don't have to satisfy all the different statistics. They just need to satisfy the ones that you care about, right? And then the issue there is that a lot of times these assumptions about the input data, they're hidden in tribal knowledge and domain knowledge, right? So for example, going back to the car age example, had I not known that it's a car, right, I wouldn't have known the range of the car, right? So, and imagine if now this is a more custom entity to your organization, then there are a lot more assumptions that are implicit in someone's head, right? That's why you really want the expert, the subject matter expert, to come in and do the fix, because they have all the assumptions, all the context. All right, continuous. This is probably like the most obvious one. So continuous data validation, right? We talked about earlier that there are just so many different ways pipelines can fail. So we said we can't test everything. And what happens today is we just test nothing, right? But really, we all know what we probably should be doing is we want to continuously and proactively validate new data as they come in. And then the other piece is probably not as obvious is that, let's see, right? So going back to the car age example, right? Like imagine if I realize the year is now 2024 and I want to make an update to my function. Now the old assumption about the year being less than equal to 2022 is no longer valid. Now I need to update it to 2024, right? So there is also continuously updating the validations based on the new assumptions and new usage patterns. This is not something we think as much about when we talk about continuous integration, continuous validation for data. Right, so the key challenges here for continuous validation, again, twofold. So one is visibility and integration. So depending on where the data validation happens, it's not always possible to keep up with new use cases, right? Again, assume if I'm the data consumer who's responsible for doing data validation, I won't always have visibility into what product teams, what ML teams are using the tables and how are they using them. And that makes it really difficult for me to say my data must satisfy these criteria for my data consumers to be happy, right? And then the other piece is that a lot of these data quality solutions are kind of a separate surface altogether, right? So when you're updating the pipelines, you're really not thinking about going over to let's just say great expectations, right? And actually updating things over there, right? So because you have different systems, it also makes it really difficult to keep things up to date, right? And then the other thing is that talking about continuous time horizon makes all the difference, right? Like a lot of times we're looking at changes that's like day to day or week over week, right? Changes can be extremely small and inconsequential from day to day, but they can accumulate over a period of time, and then they result in major irreparable failures, right? So another example at LinkedIn. So we were seeing like very small number of data points having missing feature in this one feature, and this we saw it as like a couple users at a time, and it didn't feel like it was something that warranted a closer look. And this went on for again a few months, and then all of a sudden our model just started behaving really poorly. And we didn't push a code change. Our upstream data processing never changed. It was just really difficult to really figure out what was going on. And then we realized that this one very important feature was pretty much all empty by the time we saw that the model was failing. So being able to figure out what time horizon and potentially looking at multiple different time horizons is really important when we talk about continuous data validation. All right, I'm probably saying a lot of obvious things, so I can speed up or slow down however you folks want. Any questions, any comments so far? All right, I mean, we did our due diligence of looking left and right a couple of times.
I think we're good.
All right, awesome.
A lot of
Thank you.
knots going on over here.
Cool. All right, so integrated. This was probably the most interesting letter in CIDV. I think continuous data validation all make a lot of sense. What do I mean by integrated? Right, so this is how data validation happens today. Right, I have a pipeline, and it's running end to end. Some of it is running, passing data to each other in memory, right? And sometimes it's dumping data to disk, right, while it's running. So data validator happens as a side process altogether, right? So it's really decoupled from the data pipeline execution. It's these validators are just put on these data assets, and they're run at some regular cadence to figure out the health of these data assets, right? And from there, if there are any issues, then alerts are sent to dashboards, to Slack, to email, to PagerDuty, and these things get pushed to a data engineer, right? And then once they get a data engineer gets an alert, then they'll have to come in and see what is going on with the data, and then figure out what is going on with the data pipeline. And a lot of times you kind of need to traverse all the way backwards, right? Because sometimes where you observe the issue is not where the issue actually occurred, right? So while you're in this whole process, again, going through that whole loop of remediation, bad data keeps coming in, right? And new alerts keep coming in, and this is a lot, right? This is a lot of pressure to bring pipelines back online when they go down in production, right? So I asked Gemini for a picture of a tired and frustrated person. This is as good as it got. So the point is, this current state of affairs makes it really hard for data engineers. You sometimes are waking up in the middle of the night to just restart your Airflow. I have done my fair share of restarting my big scripts back in the day. So I guess the point is that this is necessary evil, but at the same time doesn't feel like it's still necessary, and that's why we talk about integration, right? So integrated validation, fundamentally, it's all about let's have the validator happen while the pipeline is running instead of decoupled from the pipeline, right? So the validator can then in real time intervene and say, well, actually, this operator isn't behaving correctly. There's no point in continuing to write to disk, and then it goes through the rest of the pipeline, right? So what's nice about this is that you can actually prevent a lot of issues in real time, much better than human in the loop latency is, again, hours to weeks, right? So this can happen in real time, and this can prevent a lot of issues from occurring in the first place, right? But sometimes you don't always want to stop the pipeline. Not all errors are created equal, right? So this is why we introduced the notion of safeguard triggers. And so these are basically behaviors conditioned on the validation results, right? So for example, I can have two different triggers. One says if the failure rate is less than 2%, all you have to do is just to filter out the bad data and keep going, right? This seems innocuous enough. It doesn't warrant stopping the world because, it's possible that I have really tight SLAs and my pipeline needs to keep going. Right. Or you can have something that's more drastic where now my failure rate is greater than 2%. This probably, having data flow through doesn't make sense anymore. And this is where you can now say, let's hold the pipeline and let's actually loop a person in, to take a look at what's really going on here. Right. So, this sounds great. Like, why wouldn't we want to automate a lot of these things? Like, why wouldn't we want to save the data engineers, time and sanity, right? So the reason it doesn't happen is that it's extremely difficult, right? So here are 3 of the many challenges that need to be overcome to make this happen, right? So the first one is this requires really deep integration with the pipeline execution engine. You'll have to be able to basically interfere on every single operator if needed, right? Sometimes you actually need to change the pipeline code itself to be able to inject some of this logic. And then the other thing is that a lot of these production pipelines have really tight SLAs. And if these validations are happening in real time, this can really screw with their SLAs, and because some of these checks can be very expensive, right? And on the note of expensive, if you're running a ton of these checks all at the same time, right? Like, again, if it's like hundreds of tables, 100 columns, 100 checks, this can really drive up data resource consumption as well, right? And then the last piece is that maybe it's wishful thinking that we know exactly how to intervene automatically, right, when things happen. A lot of times intervention strategy is really not known up front. And it's also possible that there really aren't any generalizable intervention strategies. Well, I have evidence to the contrary. I have talked to, I want to say, hundreds of data engineers and ML engineers at this point in the past couple of years. Turning it off and on again, very common, right? So like my data pipelines, a lot of times, it's all about just restarting it. Restarting it fixes 90% of the issues. And it really doesn't need to be, woken up in the middle of the night with pager duty to go just turn it on and off again. Okay, so we talked a lot about what CI/CD is, and we talked a lot about why it's really hard. So let's talk about how we can actually make it happen, make it practical. So the sort of challenges we just talked about fall into 3 different buckets. So there's the manual overhead of I have to introduce all of these checks, I have to maintain and manage them. The end-to-end time, right? So a lot of this is about our pipeline SLA, but also human time, right? And of course, the resource consumption. To be able to address the manual overhead, one solution is to be able to automatically generate validations as new pipelines are created, right? And this is, again, if we think about specificity, this is talking about not just adding in common statistics for new columns. This is talking about looking at the pipeline logic itself to really understand what assumptions need to be met for the pipeline to behave properly, right? So a lot of semantic understanding of the pipeline needs to happen here. And then the other thing is, if we really care about SLA, we can potentially make these validations non-blocking for near real time. So you can basically have kind of 2 work streams, right? Like the pipeline can, proceed as normal, and then we can have a separate stream that's doing these validations. And it's possible that this will finish a little later, so we intervene a little bit further down in the pipeline, but it's still better than not having something that stops you from delivering bad things all the way to the destination, right? Another example is let's just run these things in parallel, all right? So that always parallelism always helps with reducing end-to-end time. And then there are a couple of strategies that will also help us address multiple of these concerns, right? So running validations on a sample is going to drastically shrink the validation time, but it's also going to help us conserve resource, right? And another one is to be able to cache validation results across pipelines. So a lot of these pipelines are working on similar or the same data assets, and a lot of these pipelines are kind of slight variations to each other, so they all make very similar assumptions. So we don't need to rerun these assumptions for every single pipeline, right? And the last piece is really obvious. They're not all validations are created equal. Some of these are very cheap. Some of these are just looking for existence, looking for schema. And a lot of times, these really cheap ones catch 90% of the issue. So let's run those first, right? We call that progressive validation. So there's a lot that we can talk about. Let's maybe just dive into a couple of these to talk about just a little bit deeper in terms of, what it means. All right, so let's take a look at running validation on a sample. All right, so here are some standard sampling techniques. We have simple random sampling, so just take a random sample, systematic sampling, stratify random sampling, and cluster sampling, right? As you go down the stack, the sampling becomes more and more complex and also becomes more and more expensive, right? And the reason you want to do things like stratified sampling and cluster is you want to make sure that your sample is representative and some of the smaller groups are still represented when you have a small sample size, right? So you can imagine that if you have a really good sample, you can, drastically shrink the time, but at the same time, sampling is also costly, right? So the sample itself can also be cached for acceleration as well, right? And then the other thing that's very obvious and not obvious at the same time is a sample of one is also the sample, right? So here we're just literally looking at the first record to see, does it actually satisfy the schema that I'm expecting, right? So instead of running the entire query, the SQL query to realize that, some of these records or some of these columns are not there, let me just figure out what are all the columns that I need in my SQL statement and just figure out upfront whether they're there or not, whether they're in the format. Okay, so another one I wanted to talk quickly about is caching validation results and sharing across pipelines. Right, so we talked about a lot of times these pipelines are interacting with each other. They're working on the same or similar data assets, and they're also producers and consumers of each other's results as well, right? So a lot of these pipelines, they're working on very similar products, very similar applications. So again, they are making similar or the same assumptions about the same data assets. So what we can do here is instead of running the same validation over and over again, we can basically cache these results. And when it comes time for, we can first do the validation here, right? But when it comes time to run the second pipeline, assuming that there's new data that's come in, we can reuse the results from that we cached here, right, to accelerate the execution of the second pipeline. And similarly, we can cache the results here to accelerate the execution of the third pipeline. Okay, so finally, I promised to talk about how CIDV relates to Gen AI and enterprises. But before, I kind of want to just have a conversation on that. But before we do that, any questions about anything so far?
Lots of shaking head over here. So
Great. Yeah. I guess,
so you talked about doing validation at different, like I kind of got caught up on a side tangent back when you were talking about how you had the source of one thing and then the like rate expectations or whatever that's doing the validation being in a separate system and having to reconcile that. And then you went off in there and I got distracted because that's the exact problem I'm thinking about at work. So my brain went the other way. But my question is, a lot of this stuff seemed to be, to me, to be stuff that you could unit test in the code and enforce certain behaviors in the code itself. So my question is, at what point in time does the accuracy of the code matter versus the accuracy of the data, if that makes sense, right? Like you can build unit tests around your code, like for that car example, that say, if it doesn't fit in this range, then throw an error, as opposed to validating the data itself. Like, do you see a win of going one way or another, maybe having the code have more errors as opposed to validating the data? Or when is there like a real win going through the data and making sure the data is super clean as opposed to enforcing things on the code side?
Yeah, that's a great question. So one thing to consider is like, how are these data errors or how the data changes happen, right? A lot of times they happen because of the external factors, because we're relying on external data vendors. We have partner teams that are changing the behavior of the applications, and therefore changing the schema of the tables, the definition of metrics, so on and so forth, right? So when these things happen, it's really hard to write your code in such a way that guards against these unexpected behaviors. We definitely can add in a lot of these assertions in there so that this basically will just throw or log an error and move on, right? For anything that's not a proper date string that has the right year, right? The downside of that is if we bake it into actual software, right? Then if we want to change our mind about how we want to handle some of these errors, or if some of these errors, sneak in very quickly, we have to go through the software release cycle, right, to be able to change these things. So that would be one part where unit testing, or just like even just adding checks within the function itself, right, that could be prohibiting. Or yeah, I'm curious, Miria, like what are some what are some scenarios you're thinking about for your work?
Well, that one that I was thinking about in a particular way, it's we have certain guardrails around different kinds of financial information, such that we can only have certain lengths. Like, we don't want money to be, I'm using your example, I'm sorry. We don't want money to be an integer, right? So we want money to have 2 decimal places all the time. Another one that we've had come up quite a bit, that again, we've enforced in code, is saying, hey, how far to the millisecond are we going versus the nanosecond? What's the precision in your time? So I guess a lot of it ends up being into data precision, where we have a lot of things in the code that says, hey, this is outside, I guess, of our contract that we've established with the platform service. And so that's kind of a lot of how we've measured it, is by enforcing that contract up front and saying this needs to have a certain format. And then we'll have unit tests that show us what happens if it's outside of that format. That way we can get predictable errors and stuff like that. It's definitely a software engineer heavy approach, because it was built by me and another software engineer, because that's what we do. But that being said, it doesn't catch everything. Like, we definitely have a separate pipeline just for the errors that don't get caught, that go into a dead letter, that we can go figure out and debug later. So this, like, we use it mostly for known exceptions that we know will happen, and say, hey, you broke our contract. This is a known exception. But for the unknowns, we it wouldn't work that way, just like you said.
Yeah, and I think you're probably in the top 1% or 10% of teams that actually do treat pipeline as software. A lot of folks, it's a different nature of software. Sometimes it doesn't get treated as such, and testing is an afterthought. It only gets put in once catastrophic errors happen in production. And then these contracts, right, that also comes down to organizational hygiene to a large extent, right? Like, you need teams to have a more centralized communication surface and to actually communicate with each other. A lot of times the product teams, the software teams are sitting so far from the data teams that they could be changing how they do logging on a daily basis and really mess up how the records are actually getting populated into the tables.
Cool, that makes sense. Does anybody else have a question? Okay, I got another one. So this is something I've thought about for a long time, and I'm really curious what your thought on this is. It's something that I've messed around with in my head and thought experiments, and then LLMs came out and totally broke my thought experiments. So I'm not going to pursue it too much anymore. But it's the idea of certain patterns in the formats of our data. And so once the data is in a lake or a store, being able to track and look for anomalies in that and then reporting it back, that seems like a very passive thing as opposed to the integrated approach, right? Like looking in the live stream or looking at certain steps in the pipeline itself. So I guess my question is, if you have a bunch of historical data that's been sitting around, would you be able to look for patterns or anomalies or things hitting in that could then inform some of the stuff you're doing in your live pipe or on your validation there? And then thing is, I think it would be a fantastic use case for machine learning if you could point that at logs or something and say, hey, we get this anomalous thing that looks like it could be like something we had in the past, flag it out or whatever. But like I said, LLMs make that seem like a ridiculous idea. So I'm just wondering if historical data ever informs some of the stuff that you're using in your continuous integration or other stuff like that.
Yeah, I think historical data, depending on, again, the time horizon, right? Like things do change pretty quickly. So we kind of have to, be able to almost have a historian say, a lot of these similar assumptions hold up to a certain point, right? And then we have comparable history to be able to mine and figure out, how do we apply historical data, historical insights, right, to applying it
I guess my
forward.
thought is like we could say, oh, look, in this last week, we've seen a ton of messages of this type that don't fit here, but we have them stored in our data lake. Like, is there a way we could use those to detect it live instead of waiting to see what happened that week? Instead of, I agree, 2-year-old data is not going to help, but if it's pretty recent, maybe you could say, oh, we've got to, you still have to detect the trend and be aware. So there's still holes in that, but yeah, still the recent side.
Yeah, so that's why we have kind of this, decoupled approach of like having the data validation and results, and then having these like safeguard triggers based on, that are predicated on the results, right? So even if you don't have these safeguard triggers activated, right, which means we're just now passively collecting data, right, collecting statistics, right? We'll be able to see the failure rates, and these failure rates, based on what you want to do with the failure rate, with the failure mode, right? You can then introduce some of these remediation or intervention strategies. So there is definitely a way for CIDV to capture errors and surface them, over a certain period of time, and then have the human come in and be able to, instead of changing a lot of different things to modify behaviors, like, I want to filter this, or I want to rescale it in some way, right? I could just like plug in that piece of logic into the safeguard triggers and let the system do the rest.
Cool. Chris has got a question now.
I'm kind of curious, how do you think, or if you have any advice within your data pipeline on tackling data that actually is like it's detrimental to look at historicity for that data, stuff like stocks, NCAA, FIFA, that sort of stuff where there is no historical insights. And if you actually look at it from a historical perspective, your predictions are worse.
Yeah, that's a really interesting problem, and that's, it's super hard, time series regression problem that, people are still looking for solutions for, which kind of also goes back to the point of like anomaly detection, right? Like in this scenario, what is anomaly? Like I've heard from a lot of folks that one major issue they have with these like anomaly-based approaches is that I first need to establish trust in your definition of anomaly, right? So I don't like false positives because that can be extremely, time consuming, but I also don't want false negatives because now I have a false sense of security that you're going to catch all sorts of different anomalies. So I guess all of that is to say, it's really extremely, situational dependent, and that's why some of these checks can or they don't have to have any impact, right? That's why, again, these safeguard triggers, you can completely pull them out and not actually have the results affect, because as a matter of fact, in your specific scenario, they're not issues, but in some other cases, they might be.
Right. I'm asking, so my team ends up doing kind of a Band-Aid solution where we take a distribution of, our training data or validation data, and then we end up comparing that against data that comes in that we're ingesting. And all that really does is show whether or not it's the same distribution. It doesn't really show whether it's representing the problem any better. And I was wondering if you had any insights there.
Yeah, so early on when we're doing ads, we found it's helpful to just increase the time window a little bit too, right? Like if I'm comparing Saturday with Friday, I'm going to be in trouble. But if I aggregate, if I look at the trend over a week, right, like over some sort of seasonality or some sort of repetitive pattern in time, that can help. But again, you kind of need to have a lot of domain knowledge to know that, for example, people don't click on ads on Saturdays because they're not staring at their LinkedIn. Right? So you still need to bake in some of these domain knowledge to be able to say, this is the period over which that, I would expect, from season to season, from week to week, from month to month, they should roughly look the same, even though from day to day they don't.
I love that answer. I think I want to just say it a bunch of times over and over again. You need domain knowledge. You need to be interdisciplinary in order to do a good job here.
Okay, another question.
Let's see. Is it on? Yeah. I had a question regarding one of the slides before where we talked about some of the benefits of this kind of different approach than what's sometimes done. There's obviously some drawbacks there, which then were outlined in some ways to mitigate those drawbacks. My question is, it seems like some of those approaches that then mitigate the drawbacks also mitigate the benefits that we would have gotten. So like, for example, the one that I'm thinking of specifically is like, we proposed that we could put a non-blocking validation check. We'll run it in parallel and then let it just proceed down the pipeline. It seems like then we're getting notified that it's failing earlier in the pipeline, but it still goes through all the way at the end. Just curious what your thoughts are on that.
Yeah, so this is kind of a compromise for pipelines with extremely tight SLAs, right? Like there are things that are running every hour and they need to deliver deliver data to the destination within the hour, right? So in these cases, we can say, there's no way for us to add in any sort of validation because I can't mess with my SLA. Or as a compromise, we can still have a separate stream that potentially will finish before the entire pipeline finishes, right? So we can still intervene before things actually land in the destination. So the hope here is that instead of having completely real time, we'll have near real time, and then the validation will catch up with the pipeline before things finish. But of course, if that's not the case, then I agree with you 100%. We're not really doing a ton other than recording the data itself.
Yeah, thanks. I think that helps put it into perspective where it's still opening up to a point where we can intervene earlier within the SLA and then take appropriate actions, hopefully before it gets to that final stage. Thank you.
Okay, that's all the questions right now.
Great. How much time am I out of time already?
It's been about, it's been 45 minutes. So if you have anything to wrap up, you're good. Or I can make them ask more questions. If you have more stuff, feel free to wrap it up or whatever. Or
yeah. I pretty much don't have anything. I don't know if folks want to have a conversation about, how Gen AI Enterprise folds into this, but if not, yeah, so our team, this is actually the first time I'm talking about CIDV in public at all. So hopefully this is a fun talk for everybody. This is something that we've been living and breathing for a very long time. So if you want to talk to us about very specifically at your organization, are you ready for CIDV or some flavor of it, right? Let's sit down and take a look at your pipelines and sit down and take a look at, what conditions, what assumptions, what criteria need to be satisfied, and how some of these techniques, right, not all of it, right, can be applied to help improve the efficiency and robustness of your data ecosystem.
Cool. Thank you so much. Give her a round of applause, guys.
Thanks so much for having me, folks. This has been really fun and really appreciate the questions and the conversation.
So yeah, I recorded that. It'll be on YouTube. It already is on YouTube. It's streaming. Thanks everyone for coming. Feel free to hang out. Doris's contact was on there. If you have any questions, she's on LinkedIn. Take the pizzas home. I don't want them in my fridge. I pay for a meal plan. So, and we'll see you next month. What's our speaker talking about next month, Chris? Oh yeah, meetup got deleted. So next month we have an event, we have a speaker, we just have to reprogram everything. So thank you again, Doris. And yeah, thanks for coming, guys.
Thanks, folks. Take care.